So welcome back to another episode sa ating lecture video series for this week. So in the last episode, we discussed ano nga bang ibig sabihin ng operational sa operational amplifier. And we have learned that the operational indicates that the amplifier can perform some mathematical operations. And diniscuss din natin kung paano nabubuo ang isang op-amp. So generally, ang ating op-amp is composed of a differential input stage and another voltage amplifier for additional gain, and lastly ay meron tayong output stage na typically it is just a voltage follower circuit. So these are the internal circuitry of op-amps LM2902 and LM741. So as we can observe, malaki pala ang circuitry ng isang op-amp. So parang ang hirap naman i-analyze yan, sir. So actually, pinakita ko lang po itong circuit na yan para at least alam nyo kung ano yung itsura ng isang totoong op-amp. Pero during analysis, hindi na po natin kailangan i-consider yan. Okay? Dahil actually, we can represent our op-amp as a black box. So, ano ibig sabihin ng black box? So, actually, hindi naman siya block. Basta meron tayong diagram kung saan kaya niyang i-represent yung operation ng isang circuit. So, let's say, kunwari na lang, meron tayong common emitter amplifier. So, this amplifier has a voltage gain of, let's say, 30 dB. So, actually, pwede mo siyang i-represent as a black box lang dahil ang alam natin dito is the amplifier's gain. Basta meron tayo ditong input signal, i-amplify niya po yun by this amount para mapalabas yung output voltage. So, pwede natin siyang i-represent as ganito. So, ngayon, na-represent natin yung common emitter circuit as a black box. So, hindi natin alam kung ano yung nasa loob nitong triangle na yan or this symbol. Ang alam lang natin is, basta meron tayong input signal, ina-amplify niya yon ng this amount para makuha yung output voltage. So, ang mahalaga lang dito is alam natin dapat yung basic operation ng isang circuit or ano yung pinaka-ginagawa niya. Okay, so, in this case, for our op-amp, we can consider it as a black box, having a 2 inputs and 1 output. So, yung 2 inputs po natin, sabi dito, Vin1 and Vin2 are called the non-inverting and the inverting inputs respectively. Paano yung main operation ni op-amp? So, nabanggit ko po yan before. An op-amp amplifies the difference between the 2 inputs. So, nabanggit ko na similar siya ng operation sa ating differential amplifier dahil ina-amplify niya yung difference ng 2 input terminals natin. So, the voltage gain is denoted by A0, in which A0 or AO na lang is called the open loop gain. And the output is defined as A0 multiplied by the difference of the 2 input terminals or input voltages. So, ibig sabihin, every time na makakita tayo ng op-amp na symbol, wala tayong pakialam kung ano yung nasa loob ng ating op-amp. Ang mahalaga, alam natin ang output niya is just the amplified version of the difference itong Vin1 and Vin2. Okay? So, tandaan, yung voltage na nakakonect sa non-inverting or sa plus, siya yung positive. And yung connected sa negative or sa inverting terminal, siya yung negative. Kaya Vin1 minus Vin2 dahil Vin1 is connected sa non-inverting and Vin2 is connected sa inverting. So that's basically the operation of an op-amp. So sir, what is the ideal value ng A0 or AO, the open loop gain? So these are typically the specifications of an op-amp. We have voltage gain or the differential voltage gain, in which it is defined as the output voltage over the difference of the 2 input voltages. Input impedance, output impedance. So, as usual, pag meron tayong amplifier, meron tayong input and output impedances. And speed or bandwidth. So, for the ideal values of these parameters, ang ating open loop voltage gain should be infinity, input impedance should be infinity, output impedance should be 0, and speed or bandwidth is infinity. So, mapapansin natin sa lahat ng op-amps, ang ating voltage gain ay really high. Diba? So, sobrang tataas po nito compared dun sa mga na-design nyo na voltage amplifier sa summative assessment nyo sa inyong lab. Diba? So, the input and output impedance, ang ideal value niyan for a voltage amplifier is infinity and 0 respectively. So, bakit infinity ang input impedance and 0 ang output impedance? This is to reduce our loading effect. So, imagine nyo na lang meron tayong amplifier dito. For a voltage amplifier, its output impedance is in series dun sa output. So, maglalagay lang tayo ng resistor dyan. And koconnect ko siya sa next stage na merong input impedance na ZI. So, ano kaya effectively itong Vx na yan? Or yung voltage na nakikita sa input ng ating second stage. So, effectively, this should be VO times ZI over ZO plus ZI. So, kung hindi ideal yung values ng ating ZI and ZO, effectively, makikita natin that Vx will be less than VO. So, yung point na tinatawag natin na loading effect. So, yung nakikita sa input ng susunod na stage is not equal to the output itself sa previous stage. So, I think na pag-usapan na natin to, paano natin iiwasan yung loading effect. So, one way is to increase our input impedance. Dahil kapag in-increase natin yung input impedance dyan, so let's say ZI is approaching infinity, ang nangyayari is si VO is approaching to Vx. Or palapit ng palapit yung Vx sa value ni VO. So, yun po yung ideal value ni input impedance. For output impedance naman, ang ideal value niyan is kapag yan ay naging 0. Dahil kapag naging 0 yan, magiging ZI over ZI, then magka-cancel out po yan. So, masasabi natin that VO is equal to Vx. Kaya ang nangyayari, for ideal input and output impedance, siya ay infinity and 0 respectively. For speed or bandwidth, ang ini-indicate niyan is kahit anong frequency ng ating input signal, ma-amplify niya po. Okay, wala tayong higher cutoff or lower cutoff frequency pagdating sa ideal op-amp. Pero as we all know, wala po tayong ideal na device or ideal na circuit dito sa mundo. So, kahit kailan hindi natin ma-achieve tong infinity na voltage gain or the open loop gain, infinity na input impedance, 0 na output impedance, and bandwidth of infinity. Siguro makukuha lang natin in real life is very close to that value. So, let's say these two examples of op-amps, LM2902 and LM741. So, makita natin ang ating open loop voltage gain ay quite high, di ba? And the input impedance, so medyo mataas, 2 mega ohms and several mega ohms sa 2902. Output impedance, medyo mababa. So, siya ay less than 100, less than 100. And for bandwidth, it is in megahertz range, so mataas po. Okay, so paano ba tayo nag-analyze ng circuit? So actually, yung real high open loop voltage gain ng isang op-amp can lead to an important observation. So kanina ang nakasulat doon is Vout is equal to open loop gain multiplied by the voltage difference ng ating inputs. So ngayon, pwede nating i-rearrange yan para makuha natin yung V-in1 minus V-in2. So pag nire-arrange natin yan, lalabas is V-in1 minus V-in2 is equal to Vout over A0. So ngayon, ang ating op-amp circuits, usually ang kanyang output is finite, hindi maging infinite yan. Kasi kung imagine mo nga naman, if you have an ideal value of our voltage gain which is infinity, kapag nag-multiply ka dyan ng input voltage, dapat ang output infinity, di ba? Okay, so totoo po yun. Pero, meron kasing case kung saan ang ating output voltage is not infinity. Okay, so makikita natin mamaya ano yung mga cases na yun. Okay? Kapag ating output voltage is not infinity, so just a finite output voltage, let's say for example 2 volts, makita natin that 2 volts divided by a really large number is approximately equal to 0, di ba? So we can say that this is approximately equal to 0. So therefore, if our op-amp is approaching to its ideal state or pataas ang kanyang open loop gain, approaching to infinity, makita natin that the difference between V-in1 and V-in2 will be approaching to 0. Or makikita natin that V-in1 is approximately equal to V-in2 kapag mataas po ang ating open loop gain. Okay, so kailangan po natin tandaan to for derivation ng ating mga voltage gains sa ating op-amp circuits. So another thing to consider is what will be the output swing ng ating op-amp. Dahil kung i-analyze mo, okay, our output voltage is input voltage difference times the open loop gain, which is infinity. So, dapat our Vout is infinity, di ba? So, meron ba tayong voltage na infinity? Actually, hindi po tayo makapag-produce ng voltage na infinity. So, lagi tayong merong limitation sa circuit. So, alam natin ang bawat circuit may nagpa-power dyang supply voltage or some DC power source, di ba? Dahil alam natin yung circuit sa loob ng op-amp dapat meron yung biasing points. So para mapagana natin siya, dapat meron tayong supply voltages. So ngayon, ang ating output voltage cannot reach infinity dahil limited lang tayo sa voltage na VCC and VEE. Okay? Dahil yun na yung kaya mong isupply sa kanya eh. VCC and VEE lang eh. So let's say you have positive 5 volts dyan and negative 5 volts. So, ang kayang i-output lang na ating circuit is until positive 5 hanggang negative 5. Dahil yan yung supply mo eh. So, ibig sabihin, imposibleng makakuha ka ng positive 6 na output voltage dyan. Okay? Dahil, saan mo kukunin yung isang extra voltage dyan, di ba? Wala kang pagkukunan yan, di ba? So, bawal po mangyari. So, actually, it's not exactly equal to VCC and VEE. So, usually, this is less than. So, practically, this should be ganito. Wala dapat equal sign. So, dahil usually, hindi naman natin nare-reach yung ating supply voltage rail pagdating sa output. So, tandaan, hindi tayo pwedeng makakuha ng output voltage greater than sa ating supply voltage. So, yun na po yung basics for our operational amplifiers. So, we can now proceed to our circuits po. So, first circuit na op-amp based is the comparator. So, si comparator, based sa pangalan niya, it compares the voltage levels between the two inputs. So, tinitignan niya lang kung sino yung mas malaki and sino yung mas maliit. So, an op-amp based comparator is essentially an op-amp operating in open loop. So, mamaya pupuntahan natin what is closed loop. Ano nangyayari sa ating circuit kapag meron tayong closed loop. So, in this case, wala tayong mga feedback. So, ang tawag sa kanya is in open loop operation. So, kung i-recall natin, ang ating output voltage is the open loop gain times V in 1 minus V in 2. So, let's assume na ideal muna ang ating op-amp. So, ang mangyayari if V in 1 is greater than V in 2, so mas mataas to, si 1 kaysa sa 2, lalabas dito sa difference will be positive. So, ang magiging output voltage natin ideally should be positive infinity. And kung baliktad naman, V in 1 is less than V in 2, ang mangyayari is this factor, V in 1 minus V in 2, will become negative. So, ang lalabas dyan is negative infinity for V out. Pero we have learned that for an ideal op-amp with supply voltages, limited lang tayo sa VCC and sa VEE niya. Ay, baliktad to. This should be VEE. And this is VCC. Okay. VEE is the negative supply voltage and VCC is the positive supply voltage. So, therefore, instead of having an output of positive infinity and negative infinity respectively, ang mangyayari is magkakaroon lang tayo sa highest possible output voltage which is VCC until the lowest possible output voltage na VEE. So, ito po yung lalabas. So, if V in 1 is greater than V in 2 or the positive is greater than the negative, lalabas dyan is positive supply voltage which is VCC. And if V in 2 naman is greater than V in 1 or yung negative mas mataas kumpara sa positive, ang lalabas na ating output is the negative supply voltage which is VEE. In this case, ang ating circuit ay actually na-connect sa 5 volt and negative 5 volt supply. So therefore, kapag V in 1 is greater than V in 2, meron tayong positive 5 volt na output. And V in 2 is greater than V in 1, meron tayong negative na 5 volts sa output. So as we can observe over here sa ating simulation, V in 1 is the blue one and V in 2 is the red one. And the output yung kulay black. So at this region, makikita natin that yung red ay nasa taas ng kulay blue. So it indicates that V in 2 is greater than V in 1. So kapag V in 2 is greater than V in 1 in this region, makikita natin ang output natin is constant at negative 5. And dito naman sa kabila, makikita natin that nasa taas yung kulay blue, tapos nasa baba yung color red. So ibig sabihin, our output voltage will be positive 5 volts or VCC at this region po. Okay, so ganyan lang po nag-ooperate si comparator. Tinitignan niya lang yung voltage level at this terminal and at this terminal. Kung sino yung mas malaki, kung si positive mas malaki, edi positive supply ang ating output. Kung si negative terminal naman mas malaki, edi ang ating sagot ay negative supply voltage. So, yun lang po. So, kung i-observe natin dito, no, ang magiging output lang natin is either negative or positive 5 lang. Eh kung meron kang sine wave na input, gusto nating i-amplify yun. So, for example, I have a 1 volt peak-to-peak na sine wave, gusto kong i-amplify by 2. So, dapat ang itsura niyan is still sine wave pero mas malaking version lang. Pero kapag ginamit mo yan sa isang open loop na op-amp, ang magiging output niya is either negative 5 lang or 5 volts. So, expect natin na magiging output niyan is parang square wave, di ba? So, yung sine wave naging square wave. Gusto ba natin yun? Of course, ayaw natin yun. So, we need to find a way to reduce the voltage gain. Okay, dahil nagpapa-infinite sa ating output, is the voltage gain dahil infinite ang ating voltage gain. So, paano natin gagawin yon? So, one way to reduce the circuit's gain is to use negative feedback. Okay, so, the diagram below is the typical block diagram of the negative feedback amplifier. So, this is the amplifier itself na merong open loop gain. And ginagawa natin is nagsasample tayo sa output or kumukuha tayo sa output tapos binabalik natin siya sa input. Okay, so kaya siya tinawag na feedback. And negative, dahil actually yung sinample mo sa output, isa-subtract mo dun sa input. So just imagine wala tayong feedback dyan, di ba? So ang mangyayari is parang zero lang yan. So wala yan. Pag wala tayong feedback, parang zero lang tong negative na yan. So mangyayari siya ay maging Vin minus zero. So therefore our Vout will be Vin times A0. So that is the open loop case. For the closed loop case or pag may negative feedback tayo, mag-iba ang ating voltage gain. So paano natin i-derive yan? We know the signal here is Vin and the signal here is Vout. So let's say our signal over here is called Vx. So effectively yung ina-amplify ng ating amplifier is Vx. Okay, so therefore Vout is equal to A0 times Vx or the open loop gain times Vx. However, what is Vx? So Vx is Vin minus, let's say this is Vy. So nasabi natin that Vout is equal to the open loop gain multiplied by Vin minus Vy. Pero what is Vy? So makita natin meron tayo ditong isang block. So imagine nyo na lang para siyang amplifier. Kung ano yung nasa input niya, i-multiply niya, yun yung magiging output. So in this case, yung nasa input niya is, ayun o, papasok sa kanya is Vout. So therefore, Vy can be expressed as Vout times beta. So pwede natin i-substitute dito yan. Yan. So ganyan lang is konting algebra and ang lalabas dyan is, eto po, lalabas na Vout over Vin. Siya ay magiging A0 or the open loop gain over 1 plus A0 times beta. In which beta is what we call the feedback factor. So ang ating ma-observe dito, originally if beta is 0 or wala tayong feedback, makikita natin that AV is equal to the open loop voltage gain. So which is really high. Mataas yan. Pero nagkaroon tayo ng beta, ang nangyari is nagkaroon tayo ng divisor dito, di ba? So effectively, napababa natin yung voltage gain from A0 or sa open loop into this one. So this one kung saan meron tayong feedback is less than the open loop gain. Ayan. So nagagawa natin is napapababa natin ngayon yung gain ng isang circuit. Kapag nag-introduce tayo na, so actually if i-apply natin sa ideal op-amp in which the open loop gain is infinity, ang lalabas ngayon na voltage gain is just 1 over beta. And ang maganda kasi dyan, si beta is typically dependent or nalalaman yan through the external components like resistors and capacitors and inductors. So ngayon, ang ating voltage gain is now not dependent to the open loop gain. Okay? So wala ka nang nakitang A0 dyan. Kapag ang ating A0 or the open loop gain is very high enough. Okay, so let's try deriving some voltage gain sa mga amplifiers na merong feedback. So first circuit is what we call the unity gain amplifier. Or minsan tawag dito is just the voltage buffer. So paano natin i-derive yung kanyang voltage gain? So madali lang po yan. Gagamitin lang natin yung definition ng output voltage ng ating op-amp. So we know that Vout is equal to open loop gain times V plus minus V minus. So pinalitan ko pa yung pangalan ha. So ginawa kong inverting and non-inverting na voltage. Sir, what is V plus and V minus? So titignan nyo po dito sa ating figure. So ano ba yung voltage na nakakonect sa plus and minus natin? So obviously nakita natin si V plus nang nakakonect sa kanya is V in. How about V minus? So si V minus naman, ang nakakonect sa kanya is V out. So ngayon, alam na natin kung ano yung V plus and V minus. Pwede natin yan ngayon i-substitute dito sa original equation for our op-amp. So therefore, V out is equal to, and konting algebra lang para makuha natin yung ratio ng V out to V in, ganito ang lalabas dyan. AO over 1 plus AO. Okay? So, ito po yung kanyang gain kapag given po ang ating open loop gain. Kasi typically, sa ating op-amp, wala po tayong makikitang open loop gain na infinity. So, to know what is the exact voltage gain of a circuit, pwede natin gamitin yung gantong approach in analyzing the op-amp. So, hanggang dito lang muna tayo. Isang example lang muna. For the next one, tatry nating isolve or i-derive yung practical na voltage gain of inverting and non-inverting amplifiers. So, I will see you in the next episode. Bye!